2.7 is prove angle pair relationships. The first theorem for 2.7 is right angle congruence theorem. The right angle congruence theorem says all right angles are congruent. We know a right angle is 90 degrees. So if we have two right angles, we know they're going to be congruent because we know they both equal 90. So the right angle congruence theorem is all right angles are congruent. We need to prove it. Given angle 1 and angle 2 are right angles, we're going to prove angle 1 is congruent to angle 2. Here's the proof. Angle 1 and angle 2 are right angles is given. Then by definition, we know a right angle equals 90 degrees, so we would say the measure of angle 1 equals the measure of angle 2. And that equals 90, and the measure of angle 2 equals 90. That's definition of right angle. Then, since they both equal 90, they equal each other. That's transitive property. We're used to seeing this would be reverse 90 equals angle 2. So if you call this substitution, that's fine. I think I would call this substitution rather than a transitive because it's not set up like a chain. You know, you can call it either one, transitive or substitution. If you're in doubt, call it substitution. Transitive is always substitution. And then the last part is just a formality. Going from measure of angle 1 to just angle 1 equals a measure of angle 2 to just angle 2. That's the definition of congruent angles, or definition of congruency. If their measures are equal, then we know the shapes are congruent. So you just say definition of congruency. All right, any questions? Okay. Linear pair postulate. Thanks. The linear pair postulate says if two angles form a linear pair of angles, then they are supplementary. Linear means line, pair means two. So if two angles form a linear pair, then they're supplementary. A linear pair looks like if I've got a line and an angle on that splits the line, that's a linear pair. If we drew it, it would look like that. That's a linear pair. Two angles, these two angles make a line. When are angles in a linear pair equal? Okay, if they're both right angles, then the linear pair angles are equal. Looks like that. That would be a linear pair. That both angles are equal. They're 90 degrees. All right. Questions? Congruent supplements theorem. If two angles are supplementary to the same angle or congruent angles, they are congruent. So this is saying, Tommy, you need to get your head out of your hands. This is saying if angle 1 and angle 2 are supplementary, then angle 3 and angle 2 are supplementary. And angle 3 and angle 2 are supplementary. Then we know angle 1 and angle 3 are congruent. And that makes sense. So we could say this is angle 1, this is angle 2. And then the 1 and 2 are supplementary. Then you draw angle 2 again, and this is angle 3. Angle 3 and angle 2 are supplementary. So since 2 is the same in these, then 1 and 3 would have to be the same measure. Now for the congruent, if you can't remember that name, that's kind of hard to remember, congruent supplements theorem, you can just write the rule. If two angles are supplementary to the same angle, they are congruent. If you just write the rule, that's fine. The congruent complements theorem, same idea, only using complementary angles. If two angles are complementary to the same angle, or congruent angles, they are congruent. If 4 and 5 are complementary and 6 and 5 are complementary, then we know what from this theorem? What would I know? Yes, angle 4 and angle 6, yeah, are congruent. Congruent complements theorem. All right, any questions? Vertical angles. They share a vertex. And they are opposite each other. Okay, so angle 1 and angle 3 are vertical angles. They share a vertex. And they are made by lines. Now, what you have to be careful about vertical angles is just because they are opposite of each other doesn't mean they're vertical angles. If I have something that looks like this, there, 1 and 3 are not vertical angles because they're not made by the same lines. This line continues on this way. Right? So 1 and 3 would not be vertical angles. Vertical angles are, they share a vertex and then they're made by the same lines. Alright, so 1 and 3 in that picture would be vertical, 2 and 4 are vertical. Sketch and label a linear pair of angles. Go ahead and do that. Sketch and label a linear pair. That's just part of it there. Sketch and label the rest. Alright, if I sketch and label the rest of it, I would extend the ray, and now I have a linear pair of angles. Vertical angle congruence theorem. The vertical angle congruent theorem is that vertical angles are congruent. If you use this in a proof, all you need to say is VA. All right? Just say VA. I'll know what you're talking about. So, we're going to prove this. We're given angle 5 and angle 7 are vertical angles. We're going to prove angle 5 is congruent to angle 7. So we start out with our given. You're always going to start out with the given. So 5 and 7 are vertical angles. That's given. Next step, we would say angle 5 and angle 6 are a linear pair, and angle 6 and angle 7 are a linear pair. Why can I say that? Why can I say they are a linear pair? We know they share they make a 5 and 6 make a supplementary pair of angles, and they share a ray. Same with 6 and 7. Why can I say they are a linear pair? All right. That's simply the definition. You would just say definition of linear pair. You don't need to say as shown in the diagram like it does here, but claiming the two angles are a linear pair, and it's illustrated here, that's by definition. Next step. Angle 5 and angle 6 are supplementary. Angle 6 and angle 7 are supplementary. How do we know that? We are claiming they are supplementary. And it's shown in the picture. They make 180. Okay, that would be definition of supplementary as well. Oh, they call it linear pair postulate. Okay, yeah, so the reason they call it linear pair postulate, postulate was all linear pairs are supplementary. So they use linear pair postulate. Next step, angle 5 and angle 7 are congruent. What is our reason for this? Look back at the theorems, the theorems that we have defined in this section. Which one applies here? Angle 5 is congruent to angle 7. Which one applies here? Yeah.
Vertical angles congruence.
Nope, we don't have vertical. We're not working with vertical angles here. I see what you're saying. Yeah. Yeah, it doesn't fit this this proof though. That doesn't fit this proof. It is true. 5 and 7 are vertical angles and they be congruent. But which theorem? We've got 5 and 6 are supplementary. 6 and 7 are supplementary. Kennedy.
Congruent supplements theorem?
Yeah, it's a congruent supplements theorem, which says if two angles are supplementary to the same angle, they're going to be congruent. So it would be the congruent supplements theorem. Questions? All right. 2.6. Prove statements about segments and angles. Okay, a proof is a logical argument that shows a statement is true. Proof is a logical argument that shows a statement is true. A two-column proof is a number of statements and corresponding reasons that show an argument or logical order. We've been doing two-column proofs. You have your statements on the left, your reasons on the right. You number each one. Right? That's what we've been doing, two-column proof. Theorem. A theorem is a statement that can be proven. Statement that can be proven. Theorem. Everybody have all those? Raise your hand if you're still writing. Okay. We're going to do a two-column proof. So here we are given angle 1 is congruent to angle 3. We're going to prove that EBA is congruent to DBC. So I would look in my picture and see where EBA is. EBA is this angle, and DBC is this angle, right? So we're going to end up showing that those two angles are congruent. So, what are we going to start our proof with? Faith? Yeah, measure of angle 1 is equal to measure of angle 3. That's given. We always start with your given. All right, our next statement is going to be angle EBA, which is one of the ones we have to prove is congruent. Angle EBA is equal to the measure of angle 3 plus the measure of angle 2. What is that? What is that called? We've used this quite a bit. We've done it more with segments than we have done it with angles. But when I say 2 plus 3 equals EBA, what is that? The two parts equal the whole. What do we call that? Yes, Kennedy.
Like angle addition?
Yeah, that's angle addition postulate. Then we're going to do the same thing with the other angle, DBC. Oh, they went ahead and substituted first, okay? So, with the measure of EBA equals the measure of angle 1 plus the measure of angle 2. I went up to this first step. I took the measure of angle 3. I replaced it with the measure of angle 1. EBA equals angle 1 plus angle 2. That's by substituting. I substituted the angle 1 in for the angle 3. Substitution. Okay, now we're going to do angle 1 plus angle 2 is equal to DBC. What's our reason for that? Look at our picture. Angle 1 plus angle 2 equals DBC. Tommy, what's our reason? Anybody? Angle 1 plus angle 2 equals DBC. Look at the picture. Angle 1 plus angle 2 equals DBC. That's angle addition again. Right? That's angle addition postulate. What do you think I'm going to say next? What does 3 and 4 have in common? What's in common in 3 and 4? Measure of angle 1 plus the measure of angle 2 is in both of them, right? So if EBA equals a measure of angle 1 and angle plus angle 2, and DBC equals angle 1 plus angle 2, what can we say about those two angles? Gage?
And EVA is equal to DBC.
Yeah, that would be our next step. We would say EBA, measure of EBA equals a measure of DBC. And what is our reason for that? What is that? Two things equal the same thing, so they equal each other. What do we call that? Yes, Faith? It's not you say congruence? It's not congruence. They are. You're right. They are congruent. They're equal, so you could say they're congruent. But we don't need to put it in that form because they had improved. They had m of a measure equals the measure, so we don't need to change it to congruence. But what would be my reason for saying that those two are congruent to each other? They both equal the same thing, so they equal each other. What do we call that? That's transitive or substitution. This equals that. So does DBC equals that. So they equal each other. That's transitive. You have to understand transitive property. You've got to be able to recognize transitive property. Or if you want to call it substitution, I'll accept that as well. But you have to be able to recognize that. Questions? All right, let's do another one. Yeah, I'll go ahead and give you a couple minutes here. You try to do the next one. All right, let's take a look at it. So, what's the first thing we always state in our proof? Yeah? The given. So we would state our given. Right? And what did somebody say next? What would be our next thing we could do? We use the picture to do this. The next thing you would want to do is say AB plus BC equals AC. That was in the picture. That's segment addition postulate. Segment addition. All right, so we have two things equaling AC. What do you think we're going to say next? Two things equal AC, Kennedy?
AC equals BC plus BC.
No, that's not what I would say next. If these two things both equal AC, then what do they equal? They equal each other, right? So you would say AB plus AB equals AB plus BC. That's transitive property. They both equal the same thing, so they equal each other. Now, how are we going to go from step 3? We have to get to this, step 4. Right? How would I go from this statement to that statement? What would I do? Let's underline in our proof. We've got AB equals BC. We need to end up with those two things equal each other. How would I go from that to that? What would I do? How about subtracting AB from both sides? By subtraction property of equality. AB is equal to BC, subtraction property of equality. Here's another example. We're given M as the midpoint of AB. We have to prove two things. AB equals 2AM, and AM equals 1/2 of AB. So let's do this by, we start out, we're going to state our given first. M is the midpoint of AB. If we know M is the midpoint of AB, what do we know from the picture? What would I know? If M is the midpoint, what statement could I make from that? Gage?
A and B of the endpoints.
That's true, but that's not what I want to say. You're on the right track though. What does that tell me about this segment? If M is the midpoint in this segment, yeah.
AM equals BM.
Yes, AM equals MB or BM. And that's the definition of midpoint. If you say here we say we have a midpoint. What does a midpoint do? It does that. That's the definition of midpoint. So we have AM congruent to MB. Our next statement, we want to say, okay, they went from congruent to equal. Whenever you do that, that's called definition of congruency. They call it congruent segments. Either way, you can call it definition of congruent segments or definition of congruency. Simply going from congruent to equal or from equal to congruent, we call that definition of congruency. It's just a formality. Right? But they want you to show that step. Okay, our next step. AM plus MB equals AB. We've seen this several times today. When I say AM plus MB equals AB, what am I using? AM plus MB equals AB. What is that?
Second addition.
Yeah, we're using segment addition there. That's segment addition. All right, keep in mind we want to get to AB equals 2 times AM. So my next step, I'm going to use this step 3 to try to get to that goal. How am I going to use step 3 in combination with step 4? What am I going to do? What would be my next step? Anybody see it? Okay, my next step would be to substitute for MB AM. So now we have AM plus AM equals AB. And that's substitution. Then we have to combine like terms. AM plus AM is 2AM. All right? 2AM equals AB. One of the things we had to prove. That's substitution as well. I'm replacing AM plus AM with 2AM. So I proved the A, part A. We can go directly to part B now. How do I go from this statement to that statement? What would I do? Yeah.
Divide everything by 2.
Yeah, so what do we call that when we divide everything by 2? We're doing to both sides. Same thing.
Division.
Division. We'd call it division. So that would be division. Everybody have it? No? So on these proofs, the only way you get good at doing proofs is doing a lot of them. So the rest of the period, I'm going to pass out a proof worksheet. You're going to do those practice proofs. You're going to do it for the homework. And once you start doing them, you'll start to see patterns in proofs that follow the same steps. Parts of proofs have a similar sequence. So like I said, the more you do it, the the easier they'll get, the more used to the flow of a proof that you'll get a feel for it. Okay, so you just have to practice it. I know it's difficult because you've got to come up with they don't give you any statements or reasons. You got to come up with things on your own. But if you practice and look back at the notes and see the theorems that we've introduced and apply those, you can do the proofs.